And welcome back to video number 3, which is the cow problem. As I mentioned in my last video, this cow problem is one of my favorite of all times just because it's very interesting to look at a situation. I could actually see this happening. As you guys know, I live out in the country, so I see cows all the time. I have seen the situation in action. One of the things that you could do with this is you can modify this in terms of like if you're trying to water a lawn and you have something in the way, what's the coverage of the sprinkler, based off of where it is. Anyway, we have a cow that needs to graze. How much grazing area does this cow actually use? So simple problem, but very, very, very in-depth. So let's first strategize. How are we going to be able to take a look at this problem and say, what is it we're going to be looking for? Now, I've kind of clued you in with this picture that I have 3 separate areas that I'm creating here. Those 3 separate areas are going to be what happens if the cow takes its tether, which if you remember is a 100-foot tether. So if the cow takes its tether and goes through 3/4 of a circle. So if the cow is tethered and goes through 3/4 of the circle, that's what I'm going to be calling area number 1. Now, area number 2 is going to be this sector of the circle, where this sector of the circle is going to be what happens if the cow reaches the point where it's going to start wrapping around the barn. So what's going to happen now is this is a 90-foot sector this cow is going to go through. And then we end up with our third area. Our third area is going to be this triangle right here. And what I hope you notice is those 2 portions that I just drew out, that red region and then that teal region, is going to be equivalent to this region right here. So what I'm going to do is I'm going to find area 1, I'm going to find area 2 and double it, and then find area 3 and double it, and I'm going to get the entire area. Now, one of the things that I do need to point out is if I could prove this geometrically, that's not going to be part of this video, but what happens is this ends up going straight through at a 45-degree angle through that barn, and where they meet up is along that 45-degree angle. So as I said, I can prove it. We're going to be using that fact, but that's not going to be for the course of this video. So let's start off with the blue region that I outlined. So that area 1, which is going to be 3/4 of a circle. We could use the 3/4 of pi r squared if we really, really want, just because we're involving sectors and we're involving sectors and triangles. Let's go ahead and use the separate formula, where our area is going to be 1/2 our theta. If we go 3/4 of a circle, then our theta is going to be 3 pi over 2, and then times r squared. So the formula I'm using is 1/2 theta r squared, which is what I used in the last problem. Let's go ahead, throw that in the calculator. 0.5 times 3 pi divided by 2, and then times 100. I'm just going to go ahead and say times 100, and that gives me 23,561.9. So 23,561.9. Something tells me it's not going to stop there. So 0.94490. All right, easy portion is done. On to phase 2 and phase 3. Now, in order for me to do phase 2 and phase 3, what I'm going to need to do is I'm going to need to redraw the situation just so I have a much larger picture of what I'm looking at. So if I have the barn that I'm going to draw right here, and again, I said that this portion is going to go out, and I'm going to recreate that sector where I know this is 90. I know this is 90. I know it's not drawn to scale, but this is 10, this is 10. And then what else do I know? The fact that that goes through the corner means that this is going to be a 45-degree angle. This is a 45-degree angle. And because that forms a straight line, this one has to be a 135-degree angle. So now based off of our drawing, if you remember, this is area 2. Let's go ahead and do that in red. So this one is area 2, followed by the teal region, which is area 3. So we aren't going to do this in the area 2 and area 3 order, just because we don't know enough information to find either area 2 or area 3. So this is where we're going to go back to say, what is it that we do know? I am going to start with area 3, or a triangle that involves area 3. And if you notice, I have these 3 pieces of that triangle. And so what kind of triangle is this? This triangle that covers area 3. This is a side-side angle triangle. And how do we solve this triangle? Because we need to know either this portion, so we have the side angle side, or we need to know this angle, so that we have the side angle side. Or I guess we could, if we know that teal question mark, we could use side, side, side. So what is it that we want to know? Well, let's use a lot of signs and figure out what we can do. So I know that the sine of 135 matches up with side 90. That's going to be equivalent to the sine of the angle that is opposite the 10 on the barn. Let's call that angle alpha. So the sine of alpha is over 10 is the sine of 135 over 90. So if you remember the way we solved this way back in 8.2, which really wasn't that long ago, we took the inverse sine of 10 sine of 135 and divided it by 90. So let's go ahead, throw that in the calculator. So 10, let's actually do inverse sine first. Inverse sine, let's throw a fraction bar up there, just so we make fewer mistakes. 10 sine of 135, and we are in degree mode, over 90. And I should have known that was going to happen. Let's throw a decimal point right there. And we get 4.506. So alpha is 4.50623 degrees. Now, what's the benefit of knowing alpha? It's so that I can find what I'm going to call angle beta. To find angle beta, we are going to take 180 minus 135 minus that angle alpha that we just found. So 180 minus 135 minus the alpha that we found, which gives me an angle of 40.4938. All right, great. Now that I have that angle, well, do I want to find the other side, or should I just use the area formula that we just knew with that angle? And I'm going to say, let's go ahead and find that area formula with the angle. So area 3 is found by taking 1/2 side length of 10 times the side length of 90 times the sine of that angle in between. I'm just going to write that as the sine of angle beta. So 0.5 times 10 times 90 times the sine of that angle that I just found. And I get 292.214. 292.214. Let's go ahead and say 444. All right. So area 1 that I found, let's actually add to it 2 area 3s. So let's go ahead and multiply that by 2 right now to get 584. So let's add 584.429. And from here, let's go to the red region. The red region is area 2. The fact that I have angle beta is a very, very good thing, because if I have angle beta, then I know that this, which I'm going to call theta just for fun, area 2 is going to be 1/2 theta times r squared, because this is a sector of a circle. So that's 1/2. And then that theta we find by taking 90 minus the beta. So if I take 90 minus, and let's scroll all the way back up to the beta, which is the 40.934, we get this 49.5062 degrees. So 49.5062. Now don't forget that theta has to be in radians, so we multiply it by pi over 180, and then times the radius squared, which is 90 squared. So if I take 0.5 times that angle times pi divided by 180, and then if we multiply that by 90 squared, I get 3499.39. So 3499.39. Let's go ahead and multiply that by 2. And I'm going to need more decimals. So 2 area 2's. If I add 2 area 2's, we're going to be adding 6998.777 for a grand total of, that's my 2 area 2's. This is my, oh, forgot my plus sign, so plus. This 584 is my 2 area 1's, or 3's. And then, last but not least, let's add that area 1, which is way up here. And that would be this, for a grand total of grazing area 31,145.2. Oh, 0.152. And this is square feet. Wow. As I said, that's one of my favorite problems just because it's a lot of fun. It brings back a lot of the math we've done really all semester, which in my mind is always a great thing. So it's at this time I'm going to throw a first secret thing to anybody who actually sat through that entire discussion. So first of all, I'm proud of you for sitting through it. But second of all, I have some extra credit for you. There is a very similar situation that I want you to go through. So what happens if your barn is no longer 10 by 10? What happens if your barn is 10 by 20? And your cow is tethered to one corner of it, and I'm going to suggest your cow is tethered right here. Same situation where this is a 100-foot tether. Can you guys find for me the grazing area of this cow now? I will accept the first 3 answers with a, I don't want just a number answer. Will you please send a screenshot or send a PDF would be best, the PDF of your work to my email, and I will give you some extra credit for that. So hopefully I'll have lots of submissions. Again, first 3 people with the correct answer will get the extra credit. So good luck to all of you seeking that extra credit, and for everybody else, remember, I'm Peter Beck, and I've got your back, and you've got your back.